Okay, I'm back. I heard a mower go by outside, and hopefully that'll be a little less distracting now that the window's closed. Alright, let's see here. If there's anything that we can realistically get. Bulk bag. So bag works. Cut tape. Tube. Something like this would be pretty easy. I don't want to pay extra shipping fees. Also, I guess I didn't even look at the current ratings, but I don't think we should have a problem. I would be impressed if we, like, everything's like 2-3 amps. 2 amps minimum. Some are a lot higher than that. I would be impressed if we went over that. Man, how do I get something that's already like at DigiKey, not Marketplace? Here we go. Alright, let's see if we can... So we have a few options probably, but we need to find something that's like already in Circuit Maker 2, or I have to make it. I really don't want to make it though. Ah, that one doesn't exist. Alright. Actually, let me just look it up here. Let me just search terminal block. To position. That's the wrong picture, but I think that's the right part. 2A2A41-2. Oh, it is expensive. It's $1.18 each, but oh, and there's no in stock. None in stock. Okay, cool. How about this one? $1.18, 117 in stock. Yeah, and it'll handle 17 amps or whatever. Yeah, that's fine. All right, we want this one. 1, 2, 3, 4. And then we'll flip all these around. I don't know if I'm gonna buy these things when it actually comes like time to build this, because it's just gonna be difficult, I guess, to um, Or it's just another cost thing, right? And this board's already really expensive. All right, so get that hooked up, and then I want some pins too that we can use, like jumper pins. Like headers, sorry, that's what I was thinking of. And then I guess, so there's a lot of options here, all expensive. I guess what's a good size? Maybe 4. Yeah, we'll see what we can come up with here. In stock, active, number of rows, 1. Yeah, I'm thinking something like this. Well, actually, like that would be kind of cool, sticking off the edge of the board. All right, it needs to be through hole. If that's an option here. There we go. All right, then what are our options? Yeah, honestly, this looks like the best one, but I don't know if it exists. Oh, it does. Wow, okay. What is the... Hold on. This might mess with the stream for a second. Everything's broken. All right. Huh, interesting, okay. Yeah, we'll place that. This is gonna be a little tight, but we need a few. Maybe like 1 ground and then 1 for each. 2, 3, 4. And I'm gonna do a ground for each. Oh wait, I didn't connect that up right. That's not even connected to ground. Hold on. What am I doing wrong here? This one doesn't connect. Okay. This is just the op amp out. So I'm gonna slide this way over for each one. Huh, weird. Okay, so if it's not next to this label anymore, then it's considered no longer connected to it. Come on. You have to physically drop the label on it. That's wild. All right, we'll get this sorted out. So pretty much what I'm going to do is put ground on each of these terminal blocks, and then I'm also going to connect one of these to ground and one to the power side. But I might have to move some things around a bit. All right, then we'll slide this down, maybe a couple. There we go. Okay. And then we need to flip all of these around. These ones could probably just drop in right here. Like the ground sides can probably just drop in. Like so. And then the power ones need to turn around. So 180. Okay. Hold on, I'm gonna try something real quick. All right, there we go. So now we need to connect all these up. Oops. I'm gonna have to make sure and label these too when I put them on the actual circuit board, because it's gonna be really confusing what is what. All right, now for this, I need a ground. I think I'm gonna turn the names off on these connectors, but for the time being, I'll just drop that like right there. All right, let's just do that real quick. I wish I could set this kind of stuff by default. I'll do it on all of these actually. All right, now I just gotta get all these connected up. Well, hold on. There we go. I do care a little bit how it looks. All right. I think that is all our connectors. So we should be good there. Now we need to start doing digital stuff. So we've effectively done this part now. We've done all these switches, all that. So now we're into this stuff. I think the next thing I'm probably most interested in is the potentiometers. So if we go, let's see, let me say this first actually. All right, so channel 1 voltage control, that's our input that has to be increased or decreased or whatever. And then let me just make sure before I go any farther, sanity check and make sure that this is wired up. I believe this is set up as non-inverting op amp. But I would really hate to mess it up. Okay, yeah. And then this is 120 ohms. And this is 475 ohms. So effectively just under a gain of 5. Or a little over. I can't remember. So 1 plus R over R, yep. Okay. So since that's good, digital potentiometer. All right, in stock, active. This one we might have to actually make ourselves. It also shouldn't need a lot of current the way it's working, so we might be able to do a multi-channel thing if that's possible. So let's start with that, and then we wanted a through-hole component, just for ease of use. Okay. Sorry, I was just checking something. All right. So for $116, we can have a 4-channel digital potentiometer. Let's not do that. I guess tube is really what we want, so that we can buy them individually. So our number of circuits is 1, 2, or 6. It's probably like 1 with 6, right? $13. But you have to buy 54. Yeah, I'll pass. Oh, I think I wanted these to be SPI as well, so... Although I could get away with serial, or I2C, honestly. Let's just see what we can come up with. I think SPI is going to be my go-to because I feel like that's the easiest for me to just work out, but... All right, 50k ohm. I guess it really doesn't matter what the resistance is because we're just going to be controlling, yeah, the output voltage value with it. We do want it to be linear. Let's see how many 2-circuit ones there are as an option, because that would save us a part at least. I'd be willing to spend $1 per if I could get 2 of them out of each one. SPI, 100K, 50K, 10K, 5K. Okay, this is something I need to check just to make sure. There might be like, I don't know what the input like current required is on the op amp. Hold on. It's the op amp TLE 320 1NE. 1INE. What? Hold on. Give me part number. $6 part. I forgot about this being so expensive. Sheesh. All right, give me just a sec. Ugh. So what we're looking for is the current required on input to these. I don't think it's usually not very high, but on the input of the plus minus. I'm hoping it's in the micro or nano amp range. Supply current under no load is pretty low, but obviously under load it's going to be really high. I don't know, actually. This may not be something that's... I'm not sure what this input bias current is. I need to figure that out. That's the only one I don't understand. Apparently it's a lot more complicated than I thought. The term input for both op-amps and fully differential amplifiers refers to DC currents flowing into or out of the amplifier's input pins to create a defined operating point during normal operation. Okay. So that's what's moving around on those pins, and since it's in the nanoamp range, we can basically just ignore it. It's so small that it's not going to affect anything. At least in this scenario. There are, I imagine, scenarios, especially with signals and things like that, where this would matter a lot. So I think we go with just a 10K potentiometer. Because there's no reason to like use way higher a value than you need to, but so if I could ideally get one of these, that would be great, but I don't know if they exist in Circuit Maker yet. $10K plus or minus 20%, geez. Oh, it does exist. Cool, and I only need 2 of them. This might save me on some lines as well. SDO, VSS. All right, cool. So before I place that, I think I need to do another page because there's not enough room here. I don't know what changed on this page. Interesting. All right, let's see. Let's do a, here, I'm gonna, actually, no, not that. Let's do new schematic, and we'll do just digital logic. And this is where we're gonna have a ton of different stuff. But first and foremost is that one we just looked up. We need two of those. Okay. Now I need to go, since I've already picked it without double checking things beforehand, I need to see, I guess we need up to 5 volts coming out of this thing. So I didn't think to check that. Voltage supply, 1.8 to 5.5 volts, okay. That works. Hopefully I can use 3.3 on the logic pins though. .8 to 5.5 for device operation. Okay. SDI, SDO multiplexing. That might be something worth looking into to figure out how to connect it up. VSS up to 7 volts. Up to 12 volts on the SPI pins, geez. Maximum output current sourced by any output pin. That's fine. We won't have an issue there. Okay, what I'm curious about is voltage range. 8 volts, basically. Okay. I'm curious about the thresholds for the SPI pins. Output low, output high is 0.7 VDD. I suspect that the inputs will be the same, which that might be a bit tricky, so we might have to do something to account for that. All right, this is just communication. Is there an ideal circuit? Excuse me. There's a lot to this data sheet. Oh, does mine have 2 pins or 1? Separate SDI, SDO pins or not? SDI. It does have separate, okay. That makes this a little easier to wire up, so I don't have to do this weird thing. 4231 is the one I'm looking at. So we just do like this. Looks like we don't need any resistors or anything. So that's good. And then more data on this. Where are those thresholds? All right, let's look at this again. They just have timings. Well, based on what they said, it's probably 0.7 times VDD. That's most likely it. So I think we're going to have to use a converter, a level shifter. Or we use a bigger gain on our resistors too. So 5 times 0.7 is 3.5. Yes, so yeah, it's too high. I was hoping for some really low threshold voltage, but I guess talking back to it would have an issue, so we pretty much got to do this anyway. All right. Well, I think we're going to go with our standard BSS 138 level shifter circuit. And since we're already using these elsewhere, it's pretty easy to use them here. Go find the ones we're using. These ones. All right, let's get a new part. And then we're going to need an in and an out for each of these. I don't know if we need it for other things on here, so hold the phone on that one. Well, but I know at least... Oh, dang it. Not that. That. That's what I want. All right. 1, 2, 3, 4. Okay. I might move these over here and have these over here. It's just their own separate level shifters. Okay. Now what? The way I like to visualize these things, they need to be turned. Nope, 270. Other way. Okay, and then I didn't see if we even have any like 10K resistors, because we haven't exactly been using a lot of common components. That won't. Those won't either. I guess we haven't. Huh. All right, well I need a standard 10K resistor. Here, I'll pull this up. I could probably actually look at the ones that I already bought, because I had to have done this for the NeoPixel sign project. So maybe this would be the right part to use. No, 470 ohm. $10K. Alright, let's look at them real quick. ERJ -6 ENF 100 2V. Zero in stock. Well, it's a good thing we didn't pick these then. Man, I just bought them too. In stock. Active. Milliohms, ohms. Hundreds. Kiloohms. 10K. There we go. And then I like 0805. And there is still a lot, so. We want cut tape. So we can buy them in individuals. They're doing their best to resist that. What kind of resistor costs $15? 0.01%. Wow, that's a tight tolerance. Let's just go with these. Panasonic electric components. Typically these are already built in circuit makers, so. Also typically they're not super expensive, jeez. What happened? Why are 10K resistors at a premium now? This'll work. Literally, like, this is one where, like, the tolerance matters the least out of everything on this board so far. Hey, it exists. Cool. Alright, 1, 2, 3, 4, 5, 6, 7, 8. Turn off. Thank you. 90. If you get a chance, let me know how your Thursday's going. It's quiet today. Sorry, I need to organize these a little better. There we go. All right, almost there. Nope. All right. Then for each one of these, I think we did... Did we have to use 5 volts anywhere yet? I don't think we did. Alright, well I think I decided for the power ports I'm going to use 5 volts for 5 volts and VCC for 3.3. So, And then all of this will be driven off of the USB anyway. Oops. Why didn't that work? I'm worried that this one isn't connected the way it was messing up. Oh, look at that. It isn't connected. Why did that happen? That's odd. Wow, that's really weird. All right, and then this goes out here. And this goes out here. And these drop down. All right, so effectively we'll shift between 3.3 volts and 5 volts on each one. Okay. There we go. And now I have to label all those things. But first I need to check this stuff too, if there's any other issues with, if I need any more level shifting. Okay, I need threshold voltages. I'm looking in this data sheet again. So they use that word. Threshold. Not really. Because I'm worried about like the chip select, right? So what are the pins? The digital pins. .1 microfarad on the input, remember that? All right, just more of that. Here we go. I forgot about the clock line. Absolutely, the clock line would need it as well, and the chip select. I might only need one more because SDI, SDO can be shared on the other side because of the chip select line. So I think I only need one more of these, honestly. Hopefully this will give enough room for it. All right, and one more right there. And then I need to rename some stuff. R23, R24, and Q9. Okay, so the SDI, SDO, and clock lines are going to be tied together between the two, but the chip selects need to be separate, which is why I needed 5 of these level shifters. Oops. And then these need to be between 5 volts and ground, and then have its output. I didn't think about shutdown. Active low. Yeah, it's gonna take some thought. I don't see any reason to really turn them off. Like, when it's plugged in, I'm gonna be using them all the time. What does shutdown do exactly? Oh no, I think I read this wrong. Oh no. I totally missed this. Alright, so check this out, right? High input threshold is this. Low input threshold has to be below 0.2 VDD. High input threshold is 0.45 VDD. So basically, okay, so I should be able to drive it without actually doing all this level shifting stuff. But our output back is still too high. But I guess we could just use a voltage divider there. I kind of like the the MOSFET better though. So our high input is like less than half of our VDD, so 2.5 volts, which will definitely hit on all of our pins. So we don't. So the only one we need it on is the one that comes back. That's the SDO, serial data out. So we just need one of these. But hey, at least we spent some time doing this. That's funny. All right, so let's go ahead and add a bunch more wires here and start labeling these out. And then pretty soon we're going to get a teensy on here and start connecting up and figuring out what kind of pins we need. I think we can do it with a standard 4.0. I don't think we need the 4.1 board. 4.0 should have enough I/O, but there is a lot of... We are going to need some... Whoops. We are going to need ADCs, and I could see that being a source of difficulty. Depending on where we connect to on the ADCs, because we're going to have to use voltage dividers, and those are going to vary and everything, and oh man, there's going to be so much, like... It may be better just to... Maybe we should get an ADC chip or something. Something that's likely to be a lot more accurate. I don't know, though. We'll see. All right, so for the circuit on this, so W is the one in the middle, and then A and B are on either side of that resistance. So we need to connect, not that one, on our amp. Channel 1V control to the output on it, on each one. Okay. Actually, let me save this real quick. I don't know what's different about this one, but... So let's get 5 volts up here, and then ground on the other side for each one. There we go. And then we need the same thing down here. How's it going, Apache? We're just designing a programmable power supply, something that I can plug into my computer through USB and control the voltage output. It's got 4 channels, and they're going to be able to put out between 0 and 24 volts of DC current. And I wanted to learn how AC-DC conversion works, so I went ahead and did that too. So I actually have AC coming in from the wall, and then I'm using a transformer and a bridge rectifier to convert it to DC. So if I'm lucky, nothing will catch on fire. All right. Probably need another ground port just to clean this up a bit. All right, so that one's good. Oh, and these both have to go to ground. I forgot about that. And there we go. All right, so B is ground, A is to 5 volts, and then W is the output. So then we need, outputs are channel 1V control, channel 2, channel 3, channel 4. All right. Channel 2. And channel 4. Excellent. All right, so now our input logic lines on the potentiometer can... Hold on, where are they? Here we go. So chip select, SDI, SDO, S-clock, and shut down. SDO notwithstanding, all the others can handle 3.3 volt logic. And then we have our shifter for SDO. So I guess I just need to name these things. For the most part. All right, so we'll start with the basics. All the ones that are going to be the same. So clock lines is going to be the same. SDI is master out, slave in. So Mosey. SDO is master and slave out, so MISO. Cool project you are working on. Let's see this. Recently I built some program to change the room light based on the compile status. You can see a demo here. I don't know if that's cool. I don't allow posting links, but that sounds really awesome. You might be able to message me that or send it to me on Twitter or something, that link, because I am interested in seeing that. That's awesome. Does it, like, if the result of compiling is like an error or something, does it display like a red light versus a like a green light if it's good or something? Because that would be cool. Nice. Can it differentiate between warnings and errors? Like if you only get some warnings, it's yellow or something? Control MISO is not decided yet. All right, so shut down. Maybe we just do shut down for both of them at the same time. I was just like, that'd be cool. Like if it's like, it can just like give you all kinds of different info that way. I don't know what that label's doing up there. Well, you met the bounty. If you want it, I'll let you claim it. You just got to send me a Dogecoin address to send them to, or I guess it's just one coin, so to send that coin to. All right, for chip select. So this is channel 1, 2. So we'll name it channel 1, 2 CS, and the other one will be channel 3, 4 CS. That's fair. It's easy to set one up. I usually use Coinomi for desktop stuff, but there's all kinds of different wallets you can use for if you want to use it on your phone or whatnot. Does Twitch allow you to DM people? Because if you can, that may be a better idea to do. That way I know for sure that it's you and not somebody else on Twitter. Not that that's a big problem right now, but you know. But thank you for telling me about that project. That's a really neat idea, and I kind of want to implement that. I'm going to find a way to implement that in my day job in the office, just to annoy the other engineers. That would be awesome. All right, so I think our potentiometers are good. Oh, we still need our level shifter. So MISO. Oh, okay. Let's rename this. This is MISO 5 volts. Whoops. All right, and then on the 5 volt side, see net label. Oh, there it is. Sorry. Having a moment. Connected the same with the video feed, so the bowl will be synced with the video. Okay, sounds good. Yeah, I want to check it out. It's a cool project, and it was nice to meet you. So this will be MISO, and then this one will be MISO 5 volts coming through the level shifter. All right. So that should be good. So now I guess what's next on the... So that's our voltage controller. And we've done all that. So all we're left with is the micro USB, status LEDs, and voltage displays. I still have not decided how I want to do those displays yet. I might try testing out a screen that I was going to buy for another project. All right, let's see, we're gonna need another schematic. Project schematic. Oh, hold on. There it goes. Name it main control, and this is where we'll put our TNC. Oh, cool. Yeah, I've not done a lot of mobile dev stuff. I took one class on it during my master's, and that was it. And my teacher was not really that great, so didn't learn a whole lot. But yeah, so it starts off really with just making the schematic. Later on, I'll be doing the actual circuit board. It's somewhat... The circuit board technically exists while you do this. It's just not up to date. So like the circuit board is here, and then all of the components that go on it are over here, not placed yet. And this is that 3D view. So a two-dimensional view makes things easier to see. But basically, once you wire everything up in the schematic, it all just connects together with these yellow lines showing you what connects to what. You place everything over on your circuit board, and then you just draw wires connecting them all together and just make sure that nothing shorts. There's a whole like there's a lot of like little knowledge in circuit board design. There's whole careers in it, and I just do it sometimes. So what was I looking for? Oh yeah, the teensy. It'd probably be my favorites. I've used a 4.1. But that's excessive for this. Oh, here's that screen I was thinking about using. Hold on. Can I copy it? Nope. Yeah, I can copy this. I want to see how expensive this is. And if it's still for sale. 0 results. Probably because I had the all this extra junk in there. All right, let's try that. None in stock. $14 though, usually. As far as screens go, that's actually not that expensive. I might just include an interface to have the display, but not actually have the display, so that I can save up and get it later. I guess I didn't have in my favorites. I didn't have a teensy 4.0. Whoa, excuse me. But I could literally pick any of them. I could have sworn I've done my own version of it, though. Hold on. No, it's just the 4.1. Okay. Well, darn. Oh, too many options there. Stick with the 4. This might have been it, because it has the ground, or the 5 volts and everything. Let's try this one. I just don't remember being a square like that, but no, I used it on, I should have known what it is. I used it on this one. By the way, you can buy these circuit boards in purple now. Yeah, I think that's the right footprint. Okay. USB is pin 27. All right, well, we'll just use this one, see what happens. I thought it seems like it was missing a pin or something. So I wanted to be careful what I picked. Well, how many analog channels does this have? Looks like 10. I think we need 8. Probably one coming off the op amp and one, well, maybe just the one. No, one after the relay on the fuse, so I can see what the output is as well. So yeah, 8 lines for that. Let's just run through this real quick. And then we have a ton of, oh, cool. I will get on that later. Just a sec. All right. Just a note for myself. And you're no problem, dude. Okay. So we have 1, 2, 3, 4, 5, 6, 7, 8. So that leaves us 3 more lines on this side. We need an SPI, so we need a Mosey Miso clock or chip select. Where's a clock line? SCL. That's clock. SCL0, SCL1. Is there any other chip select lines? All right, that's fine. We can roll without those. I think for the screen we use UART. And then how many, like, we have a lot of like on-off lines. So we have a shutdown, yeah, an enable for the op amp, so 1 each. So that's 4. We have a shutdown for each of these, so that's 2 more, so that's 6. Sorry. And then, okay, I think it's just 6 right now. Oh, I forgot about the, no, I forgot about the relays. Yeah, these 4. Okay, so I need 4 for these. And that should be it. So that should be 10. Which we should have enough there. I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Before we get to that stuff, we said 2 chip selects are needed. So that's 12, not counting this CS. Or not, ignoring the CS. 2. Then we need 2 of them. I think we're just barely going to have enough pins. Like literally down to the wire. And I don't think... Oh, man, we won't have enough for... the screen, unless we just use a transmit pin. Yeah, I think we're down to just enough. Okay, we'll try and use this. If we have to use a bigger chip, we can, but I think this will work as long as we don't add any more features. Oh, I was gonna do... Oh no, I'm already thinking of... I was gonna do LEDs to show the status of things, so I might need to do some sort of like multiplexed output thing. All right, let's just go through and start taking up lines. So 1, 2, 3, 4, 5. All right, so each of these will be the ADC lines. What? Okay. All right, so we'll do channel 1, amp, ADC, out, ADC. The reason I want to measure this one and the output is I just want to make sure that, because they are going to be slightly different, that the output of the, or A, the output is where it needs to be, and then B, the amp is not going too high to get it there. To out, AC, channel 3, amp. Apache, what kind of mobile dev do you do? Like specific platform, or do you work for on a specific type of app or something? Okay. So we have those, and now we need. We should probably go ahead and connect like shutdown lines and things. Let's do these channel 1 control through channel 4 control first. All right. And then what else do we have? Oh, I remember making the shutdown only one thing. So that saves us a line too. So pot shutdown. Okay. Amps. Open source, most of my tools on GitHub. Okay, cool. I've heard of Kotlin before. Okay, so channel 1 amp enable, channel 2 amp enable, channel 3 amp enable, channel 4 amp enable. I probably need to skip over the RX, TX. Actually, just TX. The class I took did just very basically ran over Swift and then whatever the Android language is in that environment. Is it Java? I think it might be. Like I said, I did very little of it and understand very little about it. My day job is embedded device programming, so I work in C and C++ and do bare metal and very low-level programming on chips and small devices. Okay, so that's that. Nothing there, nothing there, nothing there. We got the shutdown. Yeah, I think I remember hearing that. I had a very old professor, and he taught archaic tools. So Kotlin is getting powerful. We can build anything. Android web, front end desktop, can even write for Raspberry Pi. Oh, that's awesome. Is it like set up so that when you compile, you can just select what hardware you're compiling for? Control. I think that's everything I'm required to have here. except for the SPI. Let's see. All right, what did I name these? Mozy, Miso, SCK, and then chip select. Oh, I need two chip select lines. That can be one, but I need another. So yeah, I literally got like 2 lines left over. A framework called Compose Desktop. For backend, we've got a framework called CDOR, and to convert Kotlin code to native code, we got something called Kotlin Native. Just a heads up, these are highly experimental and active development right now. Gotcha. Full disclaimer. Don't just use it and expect it to work without bugs. Okay. Oh, I'll figure that out in a second. So Mozy, Miso, and SCK. I am totally unsure of how I'm going to do the LEDs yet. I just need... when promising for production. Dude, that's my favorite thing in the world is when somebody promises something for production and then goes to engineering and finds out that that's not possible or can't be delivered in a reasonable amount of time. Oh, it's good stuff. All right, for the chip select, channel 1.2 CS, channel 3.4 CS, that's right. All right, if this works like I think it does, 5 volts goes to VUSB, and that's an output from the device to 5 volts. Or it's VN, I can't remember. Darn it. Then 3.3 volts, we'll connect those together using VCC. And let's go ahead and drop a ground on either side. Oh no, not VN, sorry. I don't like to say on the internet where I actually am at, but southeastern US. No worries. Okay. Amp's done, so that's our main done. Did we remember to do... Oh, I never actually connected the power on these. Yeah, that's kind of important. We should do that. And then I need capacitors for them too. I think the datasheet said 0.1 microfarad is ideal. Yeah. Do I have any already? I've used a lot of different caps. I don't think I've used a 0.1. This is what I get for not actually putting the values down everywhere. All right, let's find a part then. Oof. Probably go for a few more minutes and stop. I'm getting hungry. Stock active. Cut tape. Oh 0805. Point one. All right, quite a few options. Sheesh, why are so many so expensive? It's like prices are just creeping up on everything these days. Farad, 100 volts. Yeah, that's excessive. It looks like I've used this one before. Or at least I've clicked on it before. Let's see if they already have a part made. Yep. All right, I'll use that. One there, one there. Rotate that. And rotate that. Oops. Person with an attack helicopter name. Honestly, I thought of like Apache server before I thought of Apache helicopter. But yes, maybe that's a good piece of advice. All right, debouncing cap in. Now our potentiometers probably won't glitch. Miso 5e. Why is this showing red? It should be connected. Hold on. Should be a way I can view errors or something. Yes, 100% software, especially with all the free tools nowadays. Man, even getting good software for hardware design sucks sometimes. This is free. This is Circuit Maker, but it's a variant of Altium, made by the same people, made by the company Altium. And Altium, the actual professional circuit board design tool, will run you like, I don't know, $10,000 to $20,000 a year for a license. So, and don't get me wrong, it's great. I use it at work, but it's just like, I mean, you're spending the price of a car every year for that. Yeah, it's a lot. And that's not even crazy. Like chip design software, design like an actual computer chip. I mean, you're talking 150 grand per license easy, like per seat. So somebody like NVIDIA, who probably has, 1,000 engineers working on a chip, working on the newest, graphics card, has to spend like 150K per engineer per, for each of the 1,000 engineers per year. Some of that stuff's just insane. And if I had the resources, I would make like open source or at least free versions of all of that stuff. Just so hobbyists like me could do that kind of thing. All right. I need to figure out where those line, how that's working, and then I need to figure out why this is showing an error, because it shouldn't be. Well, here, let's compile actually. Validate. MISO 5e contains multiple output pins. Really? And it doesn't like that. Interesting. I'll have to figure out a way to silence that, because that's kind of the point of SPI, right? Is to be able to connect those things together. That's fair. I'm about to sign off too. Have a good night. All right. Yeah, I'll deal with that next time. All right, I think that's pretty much everything I'm going to do for tonight. Because I do have actually an announcement to make too before next time. I'm actually going to take a break from streaming for a couple of weeks. There's something else I got to work on, and unfortunately, it's taking up all my time. So in that time, I'm going to try and brainstorm a little better how to make this easier for people to participate, or more fun to participate and watch. And but yeah, in the meantime, so you can still get in touch with me on Twitter or whatever, and just ask questions and whatnot. I promise I'll come back. And yeah, I will see you all in a few weeks. So thank you all for your time tonight. I had fun, got a lot done, and I will see you all next time.